Hello, welcome to this introduction to building command line applications with Click. I'm going to show you how to build a simple Hello World application and show you the basics of Click. So let's get started. The first thing we need to do is create a folder where we can do our work in. So I'm just going to call this Hello Click, and in this Hello Click folder I'm going to create a virtual env. So this I basically just took my virtual env venv, and my virtual env appears in the venv folder. So there's it's in here, and I can activate it by using a dot space and then venv pin activate. So at this point, my Python is in a virtual env as we expect. So the first thing we need to do when we build a Click application is to create a proper Python package, and we can do this by basically creating a setup.py module which will install our application. So let's do this. So we import from setup tools setup function, and then we're going to give our Python package a name. So we're just going to call this Hello World, and we get the version. So this is basically the minimum requirements to install something, and we're also going to define the Python module it should install. So in this case, we want to use Python modules instead of a whole Python package. So we're just going to have a hello.py file, and that's going to be our main module we want to install. We also can instruct setup tools to install other things for us as dependencies. So in this case, we want that Click is available, and we're going to set up the entry points. And the entry points is going to be basically an instruction for setup tools to associate some additional metadata with our Python package. Some of this metadata can be used by other libraries. Some of the metadata is used by setup tools internally. There's console scripts metadata is basically being used by setup tools to automatically create command line executables for us. So we're going to do this here. We are going to create a command line executable called hello, and it's going to point to the hello module and the CLI function in it. So this is all we need to do to install our Python package. If we would install it at this point, it's going to tell us that the Python module doesn't exist, the hello module doesn't exist, so let's create this. Just going to create the function CLI here and say hello world. So if we run this now, so if we pip install this, it will install our application into our virtual env. The -- editable flag is useful because it will instruct pip to use the current working directory instead of copying over all of the Python source code. This means that as we do modifications on our code, we don't need to reinstall it. So we're just going to use the current folder. So it's going to download pip from the internet, and then it's going to install our hello world script. At this point, there's going to be hello executable, and this basically is installed into our virtual env, and it's going to import this module and execute the CLI function. So let's replace this CLI function with a Click CLI function. So all we have to do is import Click, and we mark this as click.command. So we don't do anything else at this point. If we run it again, it does exactly the same. The difference, however, is that now it also responds to --help and gives it an automatic help page. In this case, it tells us the application called hello. There are options available, but the only option we have implemented is --help, which is the default. So let's add more options. For instance, we can have an option called string, and this is going to be passed here. And we can set the default here, and so we say the default is world, and then we do print hello string. And if we run it again, it says hello world, but if we go to the help page, we'll see there is now a string available. So we can do a string, I don't know, town, and it tells us hello town. Now, before we go any further, I want to point out that obviously this print function here is not a function, it's a statement. So this is obviously Python 2.x I'm using. And the print, I would say that the print statement and the print function, both of them have some problems with dealing with bytes and Unicode. So Click provides a function called echo, which works much better with bytes and Unicode. And it will automatically figure out how to print properly in however misconfigured your terminal is. So you can use click.echo, which does pretty much the same thing. As you can see, it does the same thing. but it automatically handles Python Unicode for us. And also it has the same behavior in Python 2 and Python 3. So I would strongly recommend using click.echo instead of the print function whenever you write a click application. So as you can see, there is a help page available, but this help page doesn't tell us much. So let's fix this first. The first thing we can use for adding help strings is a doc string on our function. Just going to call this this script greets. And then if we run help again, we can see our help text appears here. Obviously there is no help text for this yet, so let's do this. Help text here goes with this help parameter. We can say this is the thing that is greeted. And then if you do help again, we can see this appears here. What you can also see is that the parameter type is defined as text. So this makes a lot of sense because in this case we have a string. But let's add another one, which is going to be how often it's going to be repeated. So we're going to call this repeat and say the default is 1. Help is how many times you should be greeted. And this is obviously passed as repeat. And this is going to be an integer now. And the reason it's going to be an integer now is because the default is defined as an integer, and click automatically derives the type of the parameter from the default value. You can also be explicit by saying type is int, and it will have the same effect. I can say type is float, and there will be a floating point value. So let's do for x in its range repeat, click echo. And if you go to the help page, we can see it's now an integer. And if we do repeat 3, it's going to print this 3 times. If we pass an invalid value, obviously we're going to get an error. It's not a valid integer. One thing of note is that this option string here corresponds to the parameter here. The only difference is if you have any dashes in it, it will be converted to underscores here. So let's add another thing here. Right now it always prints to standard output. So let's make it print to an optional file. And in this case we don't want to use an option, we can use an argument. Arguments and options are similar. The main difference is that an option is optional and it always starts with a dash or a dash dash or another symbol, whereas arguments come after options and they are sort of mandatory. While they can become optional, you can't have multiple optionals because otherwise Click gets confused and doesn't know which ones go to which. But you can make them optional. So in this case, we're going to call this argument out. So we're going to write this into a certain file, and we're going to say that the type of this is a click type, and it's in fact going to be a file type. And we want to open this file for writing. Now what this means is that normally typed here would be a Python type like int or string or something of that sort. But it can also be a click type, and click types are a little bit more powerful in that they can customize a lot of how Click interacts with this value. For instance, if you define a type to be a click file type, then Click will automatically open this file for us so we can directly write into this file. And we can see this by printing this out. So we can do click echo out, and we're going to see what it is. Now, if we run this script again, it's going to tell us that there's a missing argument out. So let's add foo.txt, and we can see that there's an unopened file foo.txt passed as the first argument, as the out argument. Click is very clever in how it handles these files, so you can also use a dash to indicate standard output. We can see it opens standard out in UTF-8 mode. We can also set a default here. So if we set the default to dash, the argument has a default, but we also still need to set requires to true to false, required to false, so because arguments by default are mandatory. So if we now run the script again, we can see it has opened standard out by default. One thing of note is that arguments cannot have help texts. Arguments should be documented as part of this string. And the reason for this is that it's very hard to automatically generate argument help text without being too limiting. Arguments are very specific, unlike options, and there usually are only 1 or 2. So This is how it should be used. So if you want to document this, you put into this string. Now we can use the click echo function, say we want to write to this file, and instead of writing to standard out, it will automatically write to this file if necessary. So if you do hello here, it's going to write to standard out. If you do foo.txt, then it's going to write in the file foo.txt. Obviously, we can also write into this file in any null way. So this file will have, for instance, a write method. And we can write something in here. Now, one thing that's important is that these files, they open lazy by default, which means that unless you actually start writing into this file, the file will not be opened. And this is useful because it means that Click will not accidentally create files. So if we make an error here, let's say repeat would be 42, and we want to write in the file bar.txt, well, we didn't make an error here because the input value is correct, but let's say we would have written a non-integer here, it will give me an error. But it will not actually have opened the file, so the file bar.txt doesn't exist. So it will only be opened as you write into the file. I can also show you this by removing the echo function here. So let's make this a pass. So if we run this again with the correct value this time, the file bar.txt has not been created because no writing into the file has happened. Whereas if you actually write something into the file and we run it again, bar.txt actually exists. What makes Click very powerful is that command line applications can contain sub arguments. So in this case, if we look into our script, the script is called hello and it accepts some options. But we can also have sub-arguments. So let's change this CLI to called hello. Or we call it say. And nothing has changed so far, but our CLI function is gone. So if you would actually run this now, it's going to error because there is no CLI attribute. So let's add a new one, and we call this click.group instead. We are going to use the decorator click.group instead. Click group works exactly like click command. The difference is that any group can have subcommands. And this can be done by, instead of using click.command here, we're now going to use CLI command. So it's going to attach a subcommand directly to this here. If we run this now, we can see that there is a subcommand available on this. And this is going to work exactly as it did before. It's also going to respond to help as it does before, but it's entirely nested below hello. And now obviously there's a function to this attached as well. So the question is, when does this function run? Because as we can see, if we just run hello, it gives me help page. It doesn't actually run this function here. And this function here basically ever runs when a subcommand runs. So we can say, let's make an option here called verbose. And it's passed here. And verbose should enable verbose mode, but it should not accept an argument. So we make this a flag instead. So once it's a flag, it's going to be false by default. And when it's provided, it's going to change to true. And we can say if verbose click.echo, we are in verbose mode. And you can see this now because if you do hello say, it will not run. Oh yeah, because we're not in verbose mode. So I'm going to say hello say. But if we pass the verbose flag, it will also run we are in verbose mode. So as you can see, these groups have the callback executed before any of the subcommands have the callback executed. The last thing I'm going to show you is how you can combine this here with this here. So obviously this one runs before this one runs. But the question is, how does this one communicate any data to this function? And the answer to this is basically to use the click context. And for this to work, we can create a helper class. So we're just going to call this info, for instance, or it's called config. And this has to have an empty constructor, and it can say verbose equals false here. That's all we need to do for a start. And then we can use the click make pass decorator function, which is going to create a decorator for us, and we call this pass config. This will make a decorator which passes a config object to each of the click callbacks, which is basically decorated with this decorator as a first argument. So we can do click, we can do pass config, and it will now have a config object passed. We can do the same thing here, and we'll also have a config object passed. Now, what creates this config object? The answer is, at the moment, nothing creates it, but we can make ensure equals true, and then on first usage, this config object is going to be created. So basically, when this function is going to be called, config is going to be a new empty instance of this one. And then as we call another one, the object from here will also be passed to here. So we can say config.verbose equals verbose, and then we can say if config verbose, click echo, we are in verbose mode. And then as we run this again, we are still in verbose mode, but now the communication has gone from this function to the other one. And this is a very useful concept because you can build very complex applications this way. So for instance, you can say you want to have an option here called home directory, and this is going to be a click path. A click path is similar to a click file, just that it's just a path name. And we can say config.home directory is home directory, and obviously it needs to be home directory here as well. And then if home directory is none, home directory is the current directory. And then we can say home directory is config.home directory. So as we run this script, let's say hello say, the home directory is the current folder. We can also say home directory is temp. So we can basically use, we can move common arguments which are shared between all the subscripts to the top level script. And this is similar to how Git, for instance, works. So if you look at Git itself, it accepts arguments for the Git command itself. In this case, it accepts, for instance, a work tree argument, it accepts an HTML path and a whole bunch of other things. But then it accepts a command, and the command itself accepts more arguments. And this is exactly the same way how you would build this in Click. And that's all you have to know for a start. And I hope you can build some very cool applications with Click this way.